Hello, this is Alex from Computer Science 452, and I'm going to be discussing our certificate authority for the Practical Skills project. First, a couple notes. First of all, we did actually use a DigitalOcean account initially to implement our certificate authority, but we actually tried to use that droplet with other projects as well, and there was some hiccups. So we did actually perform all the steps using the DigitalOcean server, but for the sake of integrity, I ended up just doing it on repeating all the same steps on my local host. So I'm in VirtualBox. I have everything basically set up already. I'm just going to quickly go through what we did, for setting up our CA. And while I don't have the process completely memorized, I'm going to be referencing the documentation that we will be turning in. So first things first, let's look at our config file, which, as we can see, is actually going to be our OpenSSL CNF file. So if we go locate OpenSSL CNF. We did use the first option here, so our etc SSL. And also when we're doing any of these edits, we want to make sure that we're in a sudo session. We're going to go sudo-s and password. So let's go ahead and pop into our /etc/ssl/OpenSSL. And just for this brief demonstration, I only edited one thing, and that was this line right here, basically setting the home directory for all of our CA files. That includes our private key, certificates, database, basically everything. So let's go ahead and take a look at that really fast. So as you can see, I've already made the folder. That's going to be our CA folder. And inside here, we have our certs folder, we have a new certs folder, our rec folder, private folder, as well as our index, which is our database containing what keys we have made so far, as well as a serial, which includes which numbers of certificate it is. So these folders and files are actually required by OpenSSL in terms of the topography that it requires in order to work properly. So let's just step through the process really fast, and I'll see if we can do this really quick. So, or at least in 5 minutes. All right, so first thing we're going to do is we're going to create our CA, and we're going to do that by using the OpenSSL command. And we're going to make a new request, and it's going to be an X509 certificate, and with the new RSA 496 key, so 4096 blocks, a byte of 4096 bytes, and then we're going to have that key print out, or we're going to output that key, I should say, into our private folder as cakey.pem, and that's also going to be written out to our cacert.pem, and it's going to be good for 3,650 days. So let's go ahead and run that command, and it's going to generate a certificate using RSA. And what we're doing right now is actually creating the private key for the CA, and this is what we're going to use to sign our digital certificate. So now it's going to ask us to enter a passphrase. I'm going to enter a really dumb passphrase, 1234. And it's going to ask for our country name. We're in the United States. It's going to ask for our state. We're in California. Locality, I'll just say Fullerton. And organization name, we are CPSC 452. And organizational unit, of course, we're all straight A students. If I could spell straight A students. Students. And our common name. And now this is actually the most important thing when it comes to real-world application. We want to make sure that our common name actually matches the DNS of whatever website we're trying to self-sign as. So for example, if we were example.com, we would want to make sure that we put our common name as example.com and that our DNS also reflects that. So when you navigate to our page, you're actually navigating to example.com. So in this case, since just for the sake of our demonstration, we're actually going to use localhost and see what happens. And then email address is optional. We don't need that. So now that we've created our certificate authority, let's go ahead and actually generate the certificate. And we're going to use another OpenSSL command. And we're going to make a new request. We're going to create, well, for nodes, we're going to create a new RSA key of 2048 bit bit length, and we're going to output a key to our private folder, and that's going to be our CPSC 452 key. And then we're also going to output a request as a CPS 452 request, which is going to be good for 1095 days. And so let's do that. And it's going to ask us to enter in this information again. So our country, United States. California is our province. Locality is in Fullerton. Our organization is CPSC 452. And we are straight A students. And our common name again is going to be localhost. And email address optional. And then our challenge password is going to be ABC. And our okay, I guess I can't do that, ABCDE. And our optional company name is going to be CPSC 452. Alright, so now that we have our actual certificate, let's go ahead and sign it. So we're going to do that using another OpenSSL command. Oops. And so this is going to invoke the CA command, or excuse me, the CA, I guess, verb from the OpenSSL library, and it's going to output our policy. It's going to use a policy that's defined within the configuration file, and policy anything, which is one type of policy, and that's going to go out to our certificate, into our certificates folder, and that's going to be saved as CPSC452.pem, so another private key, and then the input is actually going to be the request for the CPSC 452 request file, which is so we're going to go ahead and do that. It's going to ask us to enter the passphrase from the first from the private key that we created. So again, it's 1234. It's going to validate all this information, saying this is certified until this time, this day, length of time. Do we want to sign the certificate? Yes, we do. 101 certificate certified. Commit? Yes, we do. And database is now updated. So now what we can do is actually view our certificate. So there is some Apache configuration that we had to go through in order to do so. That's all explained in the documentation, but we're going to kind of just jump ahead here for the sake of time. And we're going to take a look at our new certificate. So we're going to go to localhost first of all, and we're going to see indeed Apache is running, and we have our default splash page. So now in order to test our certificate, we're going to do https://localhost. Oh no, our connection is not secure. However, it is a good thing because we can see that it's using an invalid certificate, and this certificate that is invalid is actually our own self-signed certificate. So as it says, the certificate is only valid for certs.cpsc452.com. And we're going to go ahead and add exception, and we're actually going to take a look at our certificate. So let's go ahead and take a look. And actually, as I was making this new certificate, I actually believe that the serial number here, I actually didn't reset that. This was actually the original certificate I made, because during this demonstration I had used localhost, but previously in the actual creation of this the first time, as you can see by the serial number 1, this was actually the initial cert that I made. So if I had reverted this back to, if I had echoed a 1 in the serial number before we did this process, this would say localhost. So anyways, we can see that our organization is CPSC 452, our organizational unit are straight A students, of course, and we can see our fingerprints of the SHA 256 digest as well as the SH1 digest, And yeah, we can see that this certificate is not verified because the issuer is unknown, and that is because we are not linked to any trusted root certificate authority. So, but on the other hand, we were successful. We were able to generate our certificate, and we do see that there is HTTPS. So let's go ahead and just confirm this security exception. And we're going to see that we have a lock, and it says that the connection is still not secure, but this connection is still an HTTPS connection. So we should be able to, this should be a connection secured by TLS and SSL. So again, this is just a quick demonstration of our certificate authority, and thank you very much for tuning in.